All right, I'm very excited to be closing us out today, and thank you for all hanging in there with us. I've been very excited to hear so many people talk about co-design, but now I'm going to bring a different technology into the mix, and I'm going to be talking about robots today. So I'm going to give you a little background on the human-robot interaction field, or HRI as I may call it. That's what I'm referring to. And so in HRI, the history has been, it's a very computer science and engineering dominated field. That's how it started. So my co-authors on this paper are both computer scientists. And there also has been a history of having psychologists come in and work on these concepts, since there's a lot of the studies between how are humans and robots going to be engaging. And now there's an increasingly amount of design researchers like myself that are entering this field and bringing in new different methodologies. And the ones that I specifically look at are how do we bring more people into the robot design process and engage with us in various ways. So I found co-design to be a very powerful way for us to ask, how can older adults engage with us as robot co-designers? And so what about co-design? So as we've heard from a lot of people, co-design is a methodology where we really work hand in hand with people to design an item, a product. In this case, it's robot interactions. And co-design allows us to take things such as this, pieces of artwork, pieces of design, or it allows us to look at these design guidelines and kind of come down to these concrete ideas that we want to move forward with as a product of our learnings together through this process, thinking about researchers and designers and the communities that you want to work with. And so co-design and participatory design are often used interchangeably. I may use them interchangeably, but in the paper we refer to co-design because it is based in collaborative design. And it really emphasizes the users are co-designers with the researchers. Now that sounds really fantastic, but oftentimes there can be an imbalance of power. And so a lot of co-design methodologies and participatory design really emphasize empowering users and communities in the process and shifting these power dynamics. So in ideal space, it would look somewhat like this. Though we often don't get to ideal, it's very important for us to really consider these power dynamics when we're engaging with communities. And so in human-robot interaction, co-design is starting to become a thing. It's very rapidly increasing, I would say. And so you have people designing robots with older adults, with teenagers, with children. It's a really wide spread of different application areas, but it's not the main method, and there aren't as many people applying it. And so for our contribution, we are looking at older adults as co-designers. And in our work, we have two different research questions. So we're really looking at how do older adults design robot interactions after they've actually lived with a robot in their homes. And then we look at the second question, which is how do older adults relate to being robot interaction designers after engaging in a prototyping experience? And so the background for this is that we did a year-long co-design process in 2019. There will be a lot of people without masks. We were following all protocols before then. We engaged with 28 older adults, ages 70 to 94 years of age. And this is the 7-stage process that we use. So this was working with the same group of older adults. And so there was initial interviewing, art-based image making, and then we had them live with the robot for at least 1 month, though people kept it on average about 5 months, for a very long period. And then the rapid prototyping was right after living with this robot. And you can read more about this in the paper that I've cited on the screen. So the application areas that we were emphasizing in the whole co-design process were looking at assistant-like and companion-like functions that you may be familiar with voice assistants, looking at how could a robot be used for medication adherence, emotional wellness, exercise, memory support, and mediating social connection with other people, so mediating human-human contact. And so the rapid prototyping interaction was right after they had lived with the robot and was a really dedicated space to design and iterate different interactions. And so I want to introduce you our robot that is featured in today's videos. This is Jibo. He is a social robot. He is actually, gendered. Though the name can actually go both ways, and people refer to it as a he or her. I just referred to it as a he. And a social robot are robots that are designed to be in people's lived spaces and will engage with you in social ways, meaning if you say its name, it'll turn to you like in the video. Or if you say something and it's wanting to show its intent that it's listening to you, it'll lean forward. So these social cues that we use as humans can be embodied in these systems. And so in this process, we had multiple rounds of iterations of older adults designing interactions. we first started off with a script editing. And this script was based on the application areas I just showed you. For example, one of the iterations or the different interactions they could work on was for a robot reminding you about your medication. And so it was detailed in this interaction, and older adults could go in, change the dialogue, change the script, make it what would work best for them in their life. So that was our first round of iteration after the script, and then we took those and had a rapid prototyping session with our older adults where they were programming and editing interactions. And I'll get more into how that looks in a second. And so in that session, there was our second round of iteration where they could continuously iterate on these interactions as these interactions could be seen live on the robot. And you'll be able to see what that looks like in a second. So what does programming a robot look like? So we started off with a demo first where the researcher that was working with the older adult showed them the system, how it works, what's the different components, and then we gave them a tutorial or a task. We asked them to write a simple programming code that would have the robot ask you, how do you like programming a robot? And then the user would respond. And so this is what it looks like to program a robot in a high-speed fashion. And so you can see there's a green block that was just added, and so this block here is a Jibo speak block. And what that means is you're typing in what you want the robot to say. The blue block that was just added is for the robot to be listening to your response. And then this person was adding in branching, which is giving different routes based on the answer. So if the person said good, it would go one direction. If they said anything else, it went the other direction. And so this is an example of what that tutorial session looked like, but it was a familiarization with our programming tool here. And this is known as a form of block-based programming. So after that, we had programming the robot interactions where we went through each of the interactions that they had designed on the script, and now it was live on the robot. And so this is an example of what that session looks like, where we're working with the older adult and they're programming their sessions in editing using our prototyping tool here. And the robot is sitting there, and what would happen is after they finished programming, they could play the interaction live. So we're gonna actually take a look at what that is, and I hope the audio works.
How did your doctor's appointment go? Is there any new information that you would like to share with me? I'd like a change in your medication and things we should look out for.
Yes, there's a change, Jibo. Instead of once a day, I need to take it twice a day now. Could you please remind me?
Yeah, so that's an interaction. You see one example of that. They programmed the interaction and they're seeing it live. And then after seeing it live, they had a chance to go back and change it some more for that second round of iteration. So the results in our paper, we look at the questions that were asked and how they were getting familiar with the system or about programming in general, the core design actions that they were performing and the iterations that were occurring, and then reflections on the co-design process. I'm just going to focus on the later two in this presentation. So what do robot interactions look like? You've seen one example of the tutorial, but that's just, a tutorial interaction and maybe not as engaging as looking at something that people were designing for themselves in their home. And I'm going to be looking specifically at the core design actions and the iterations. So what I'm going to do for each of these is I will introduce what is after breakfast interaction or the different topic, and then I'll go into the different core iterations or different actions that were being used. So in this interaction, P09 is designing an interaction where the robot is engaging with them right after breakfast. They've had their breakfast, and now the robot is giving them the run of their day and reminding them to take their medication. So the original script iterations first, that's the very, very base script, and this is the first iteration after they edit the script. And so in this iteration, they wanted the robot to give them dosage information about their medication. So they added in a speech block. They also deleted the comment because they didn't want to initiate it. They wanted the robot to just engage with them. They reworded the speech block so that it also added medication dosage information. And then they were removing some of this branching and removing some speech boxes, adding some speech boxes here. This is the second iteration. This is after they've seen it live on the robot, and they have now shifted it. So they removed, you could see some of these things in the code. So they added a comment, and this comment is saying that the user is going to ask later for more information on medication. And that means that after seeing the interaction live, they realize I don't need the dosage of medication being told to me, I'll just ask if I want it. And then they also removed this listening, so the robot is not listening for a response, it's just giving the medication reminder and then shutting itself off. And so this is the full iteration that you can see for P09. Next, I'm going to go into P22, which is their wake up one. And so in this case, their sleep. The robot acts as their alarm clock, and then it will tell them, like, you know, wake up, like, here's what's going on, and see if they're ready and if they've had a good night of sleep. So just being very friendly in the morning, which may not work for all of us. And so in their script for that particular part, they did not actually iterate anything. They didn't iterate until later down in our script for a different one, so we went up and modified it a bit for them. So we removed the comments here because they didn't want their name included. We removed the comment, but we added branching. So there was an additional one there to be like, do you want to be bothered or not waking up? And they wanted speech box added, kind of addressing that iteration. And then this is after they've heard it, listened to it, and you can see it's drastically changed. That's because they realized they didn't want the robot engaging with them after seeing it live. So they added a comment being like, they're not ready to interact, so please don't bother me. And they also deleted a lot of this part, which was really focused on, how are you doing? How was your sleep? So you can tell they much more wanted a very simplified interaction. So again, this is from the original script all the way through the second iteration. And lastly, I'm going to talk about P11 and P12 sending messages. And I talk about this one because in the previous two examples, people have been removing a lot of complexity. You'll see the opposite happen here. So in the original script, basically the robot comes on and says, you have a message from so-and-so. Would you like, and then would you like to listen to it? And then they reply, they say the message to the person, which was a filled in one saying that myself, Anastasia, is trying to reach you from MIT. And then so what they did is they didn't edit it at all. They reworded it a little bit just to make the wording more customized. So that's what this is, the rewording. And then you go to the second interaction. And this person really thrived on learning about the programming of the robot. They really took it as, I can create more branching to represent this more complex interaction. So the robot tells you the message, and then they go in and now the robot is saying, oh, here's a message. Do you want me to reply to you? Okay, what do you want to send back to Anastasia? Okay, let me see if it's correct. Is it correct or not? So they really went into the complexity of the space, adding speech boxes, adding this branching for yes or no for the reply, and adding these comments. So you can see there was a large shift of much added complexity in this space and really kind of grabbing onto this tool of being able to program this robot. But I can show you all of these, but it doesn't really do any justice except for without you kind of hearing a little bit more about why was this experience so powerful. And so I'm going to go into the reflections that older adults had of their co-design process. So this experience was very powerful to older adults, making them feel like co-designers in our process and imagine how our social robot could really impact their lives and making it a much more tangible thing after just seeing in their home what is the current robot, but this is how I could imagine it for myself. And so I'm going to play two videos that will give sort of a chance for, just so you can hear from the older adults themselves what it meant to be co-designing these prototyping interactions.
It took some of the mystery out of it. And I understand there are probably lots of different ways of doing it, but you give me a little bit of insight into the whole area of programming.
Yeah, definitely.
And it's clearly quite interesting. I've always thought of programming must be very boring, but this was quite interesting.
This really makes me feel a part of this whole study, and I appreciate that, that our opinions matter, and that even though we're not programmers or electrical engineers like our son, that we were still able to do some simple programming, and I think that's fun.
So now you heard them. I'm just going to give an overview of some of the things that we really reflected on and saw in a lot of the conversations we had with older adults, one of them being self-efficacy. And so we found that the lived experience of really having this robot in their space was a huge component for them and really helped support them in their programming. And also by doing the demo and the tutorial parts of our process, it helped us establish more of a language of co-creation, and especially having different iterations with different tools was very helpful. So people being very familiar with pen and paper and then moving to programming can be very daunting, but we did it in a way that really helped them introduce and become maybe, I wouldn't say everyone was comfortable, but they were willing to engage with us in this and really feel supported with us being there with them. The second one is empowerment. Like I mentioned, in co-design and participatory design, you're always working to empower users in the design process. And so we were able to provide insights for designs from these prototyped interactions that have actually now moved into some actual, autonomous interactions on the robot now, which is really exciting. And it also demystified the technology. Programming can be thought to be boring or, this like, how does it even work? But by breaking it down in this way, it really helped them understand what programming is and how they can be involved in it. And lastly, power dynamics. So we engaged in joint inquiry and joint imagination with our co-designers, not only in this session, but throughout. And it was a reoccurring theme for us throughout this whole process. So the thought I want to leave you with is that through promoting sustained engagement with communities and democratizing how people design, we can reshape the notion of who can, should, and is a robot interaction designer. And lastly, I just want to acknowledge the co-designers because we could have not done any of this without them, and they've partnered with us throughout this whole process, and we're still engaged with them. And I'd also like to thank Jody Ferlizzi, who is advising me on this work. And then these are our funding sources, and I'm happy to answer any questions you may have.